Morning, so please put all your devices on mute, silent, airport, whatever it's going to take so it doesn't go off in the middle of the show. Hello and good evening, ladies and gentlemen, and welcome to the June Recreational Astronomy Night of the Royal Astronomical Society of Canada, Toronto Centre. My name is Tom Luton. I'll be your host for the evening. This evening's lineup, we have Claudio Oriani with the Sky This Month. Julian Samuel will be talking about using a 60 millimeter solar telescope to make sketches and oil paintings of the sun. And then Frank Dempsey will wrap things up with some updates to the telescope loan program. And then our president, Scott Masterton, is away, so I'll be handling the announcements at the end. Just a quick show of hands. Is there anyone here in the audience here for the first time? No? All right. Anyway, and we'll get started then with Claudio Oriani and the Sky This Month.
Thank you, Tom, for having me. And hello, everyone. My name is Claudio Oriani, and from Richmond Hill, close to the David Allen Observatory, still the biggest optical telescope in Canada that just turned 90 a few days ago. Tonight, I will talk about the sky for the month of June. We have a lot of things to talk about, and let's start. So, a glimpse. Venus will be very bright in the morning sky, just reach the maximum distance from the sun. It's around 4 o'clock, 5 o'clock in the morning. If you're waking up early and you see a big light in the sky to the eastern side, that's Venus. Saturn is back after 2 a.m. and the Earth orbit just crossed the plane of the rings a few months ago. So the rings are very thin. We will see this in a few seconds. We have the chance to see the noctilucent clouds if there is a wildfire that it will give a break. And there are a lot of conjunction at close encounters. Antares that will be less than 1 degree north of the moon on the June 9th. The Mars Regulus will be very close during the entire month of June. We'll see in a few minutes. Saturn and Neptune are also dancing together during the month of June. June 19, they will be very close to the moon as well. Mars will be very close to the moon at the end of the month. And above all, we have the summer solstice. We have summer, but we also have a limited number of dark night hours. Let's see. Today, the sunrise was at 5:37 and the sunset is 8:54. So we have 15 hours and 70 minutes of daylight. On July 4th, will be sunrise at 5:41 and sunset is 9:01. What does it mean? That means that today the astronomical twilight ends at 11:12 p.m. and we just have 4 hours and 8 minutes of imaging time when it's very dark. On June 21st, the shorter night of the year on the northern hemisphere, we just have 3 hours and 48 minutes of imaging time. July 4th is not that different. We have like 20 minutes more of imaging night. And that's about the time you can use for your astro imaging or just look at the sky. What can we see during this month? Finally, we can see the Milky Way galactic core at its high during the summer. Usually the end of June, beginning of July is high in the sky, but you have to go out from the light pollution. We see a lot of star cluster like M39 Cygnus, the Laguna Trifid Nebula in Sagittarius. We reach their peak altitude after midnight. The Laguna and Trifid will be very low because in Sagittarius. But this month I will focus a little bit on the globular clusters that are easy to be spotted on a small telescope and also to be imaged from the light polluted sky. Of course, there is a summer triangle formed by the bright stars Vega, Altair, and Deneb. Venus, as I mentioned, will be in the morning sky. Mars is still visible after sunset, closer to the star Regulus in Leo. And Mercury will appear low in the western sky later in June. Also, keep a look at the Blade star, the T Corona Borealis. There were like highlights last year. It's about to explode. It's about to be a nova. We're still waiting. This can happen at any time. It's a recurrent nova. Maybe you will be the one who will be spotted first. It will be visible when this is happened for a few days with the naked eye. Stellarium time. So if you start looking at the southeastern, southwest sky, you will see, tonight there is a moon, of course, but we also have the summer triangle here. The three stars, Vega in Lyra, Altair in Aquila, Eagle, and Deneb in Cygnus. That's easy asterism you can see looking east-northeast. The northwestern sky, you will see Cepheus, and you can also see that the Ursa Major is up in the sky. So you still have some time to see some of the galaxies. Galaxy season is over, but galaxies are still there. And then southwestern sky, of course, Leo is going down, and you see Mars that is in the middle of this image here. They will be very close in the next few days. If you look overhead, Hercules, Corona Borealis, Boots, and so on. And the Milky Way, maybe you can notice to the left side of this image, I removed what is the light pollution, and if you have a dark sky, you can spot this beautiful galaxy. It's our galaxy. Let's talk about the sun. It reached the maximum activity a few months ago, but it's still very active. We were hoping to see northern lights the last few days. Unfortunately, we had a couple of issues. One, so the KP, the geomagnetic activity of the sun was very high, and there was a very, very long flare, like lasted 4 hours. So we have all the ingredients to have northern lights. But the problem is that the BZ was pointing north. So there is interaction between the magnetic field of the sun and the interplanetary magnetic field. If this is pointing south, we have a good chances to see the northern lights because there is interaction between the Earth magnetic field and the sun. The other problem, as you have noticed, pollution from the wildfires. The sky looked like orange this last few days. So no luck. We didn't see that. This image was taken a few days ago, May 9th, 2025, with my small hydrogen alpha telescope. Samuel will tell you more about this kind of beautiful telescopes soon. And this was a monocamera, so I colorized and inverted images to make the prominences bigger. Just to give you a scale, this is the dimension of Earth, and this is the dimension of the prominences. That's huge. The moon. On June 7, the moon will be at the farthest, so 405,000 kilometers away, and the perigee will be reached on June 23rd. There won't be a super moon, as people like to say now, because it won't be full moon. Phases. The full moon is on Wednesday, June 11, and it's called a strawberry full moon, I guess because it's when the strawberries are good to eat. And there's also a record because it's the lowest full moon of the year. So June, the sun is reaching the highest and the moon is reaching the lowest. January is the opposite. Last quarter will be on June 18. The new moon will be on June 25th. So if you want to take some imaging time, wait until the end of the month. And again, I always love to show this image. We see a little bit more of half of the moon because there is like interaction between the tidal forces from the sun and the Earth, and the moon is just wobbling around. So we see kind of 59% of the moon. And on June 2nd, June 12, we will see the northern part of the moon, part that usually are not visible from here. So if you are trying to spot some details that are usually not visible, just look at this slide. You can see a little bit more of the western limb, most exposed on June 16. The southern part will be visible on June 25th. So probably we'll also see, if this is going to happen, where the Artemis 3 will land. And the eastern limb will be exposed on June 29. Let's go to the moon and planets, bright stars conjunction. There are a lot of this month, so let's go very fast. First of all, June 4 tonight and tomorrow, Saturn and Neptune are very close. So the red square in this image and the next one is just showing how the field of view of a DSLR camera and 135 millimeter lens can show the sky. The two planets are in the same field of view for the entire month of June. In fact, if I go to the next one, you see that on June 30, they're still there. Just Neptune is a little bit more on the other side. The Saturn moved westward. This is early in the morning. If you see, it's 4:30, 4:20 a.m. Then we have the moon and Antares on June the 9th, and it's better because it's evening, around 9 o'clock. You see the beautiful red star, and that's probably the clue of the month. See what happened between Mars and Regulus between June 5th and June 27th. On the 14th, 15, 16, they're the closest, the 16 and 17, 17, 18. By the way, on the 16, the two objects are less than 1 degree apart. And it's beautiful to see the difference in color. Mars is red, rusty, while Regulus is white blue star. You can see the difference in the light. It's beautiful, and you have many days to try to spot them together. They're quite low the horizon to the western side. 19. Then we have Moon and Saturn on June 19, as I said. So we have a lot of things to do on the June 19. They're also together close on the eastern morning sky, around 3:20. And they are like around 18 degrees high in the sky. On the 22nd, we have the Moon, Venus, and to the left, the Pleiades. It's in the early morning, so 4:20, so probably the sky is already getting brighter, but you can definitely see Moon and Venus very easily. Pleiades, I don't know, because probably it's already clear. Next day, the Moon and Pleiades are together. You can try with the camera, and maybe you can, with a long exposure, few seconds, image both of them together. And the Moon is very, very little sliver of the Moon, around 4:20 in the morning. And again, June 29, the Moon and Mars are very close together, Regulus to the right. They're 0.2 degrees apart. That's another good photo opportunity. I believe that in some part of the world, I'm pretty sure there will be an occultation of Mars. We are done in Toronto for this year. And July 3rd, Moon and Spica are always close together, 10 p.m. Let's talk about the planets and where we can see them. This image, as usual, is from the Rask journal. And you can see for different planets, where are they, the magnitude, how brilliant they are, the diameter, apparent diameter, and the constellation, and if you're visible in the evening of the morning. So Mercury will be visible at the evening toward the end of the month. Venus is a morning star, not a star, but it's morning, and is very bright. For minus 4.4 means that you can't get it wrong, that Venus. Mars is one magnitude that's still red, still very, very brilliant. In the evening sky, we'll say goodbye in a few weeks, while Jupiter will say goodbye at the end of this month because there will be conjunction at the end of June. Saturn will appear again, and Uranus will be visible at the end of the month towards in the morning sky. Neptune is also a morning object. Let's talk about Mercury. As I say, on June 8th, it's very hard because it's probably 15, 20 minutes after sunset. They're close together in Taurus constellation. Maybe you can spot Jupiter. Wait until the sun is gone, please, because you never know. That's an animation. I took this image, this video of Mercury. It was on June 6, 2020. Venus is a morning sky, low to the east before sunrise at the end of the month. And as I said, it reached the greatest western elongation, so the maximum distance from the sun, the best time in 2025 to observe Venus in the morning sky. Mars is still reasonably high in the western sky because it's setting before 1 a.m. and is in Leo, the Lion constellation, close to Regulus, as we saw before, the kingly star. Jupiter is very hard to spot. Again, it's close to Mercury on June 8th, but it will be in solar conjunction on June 24th. So you have to wait a few months to see Jupiter again in the morning sky. Saturn is rising in the eastern sky before 2 a.m. and will be more prominent towards the end of June. Still not very bright, but if you have probably at least a 6 or 8 inches telescope, you can see the rings very thin because they appeared edge on from our perspective because the game between the orbit of the axial tilt of Saturn and the Earth is like 27 degrees for Saturn and 23.5 degrees for the Earth, plus the plane of the two planets. So we cross the plane of Saturn rings, and we saw a little sliver at the end of March. This will happen again probably in November. But then over the course of the next 13 years, we will see more and more of the other side of the rings. Uranus, not much to say here. Wait until the end of the month and try to capture the moons of Uranus. Is getting more distant from the sun in the early morning, but probably it's better to wait next month. Neptune. Neptune is still a good opportunity to see. And as I say, on June 29, Neptune and Saturn are in conjunction. Interesting fact that they will be 1 degree apart, but Saturn will be 500 times brighter than Neptune. What can we see during the month of June? We have a lot of things to do, so I had to pick some. So we have lots of galaxies still in Virgo, Coma Berenices, Ursa Major, but also starting to see narrow band targets like the lot of stuff, the North American Nebula in Cygnus and Sagittarius, M8, M20, and so on. But I wanted to focus on a couple of globular clusters. The first one is M3 in Canis Venatici, the hunting dogs. And the second one, not much to say, is the Great Hercules globular cluster, plus a galaxy. So M3 is one of the brightest and largest globular clusters in the northern sky. It's located in Canis Venatici constellation, and it contains an estimated, I can't even tell, 500,000 stars. It's also very interesting because I think it contains the biggest number of variable stars, the highest number, like 274. This is how to spot it. Is it to the right of to the right of Bootes constellation, between Bootes and the Ursa Major. And this is what you can see, or we can image with a small telescope. This was just with the 80 millimeter telescope, took a few days ago. Interesting fact that there is a little galaxy I highlighted to the right, and this little galaxy is little because it's 240 million light years away, NGC 5263. That's the Great Hercules cluster. It's 25,000 light years away, and is one of the brightest and most spectacular globular clusters in the northern hemisphere. Yet always imaging like being on a planet. So there are like also 100,000 of stars, and Can you imagine a planet that is like orbiting one of these stars and is always daytime there, and there are stars everywhere? I wouldn't love to be there. But you never know, because yeah, this is another image I took a few days ago with just 1 hour integration time. And again, there is a IC4617, is also highlighted there, that is 553 million light years away. Fun fact about the M13, probably most of you already know, is that in 1974, we sent a message to them. If there is someone there, maybe can understand. It was from the Arecibo Radio Telescope in Puerto Rico, November 16, 1974. And there are, it was in black and white. We just put the color because I wanted to, show a little bit better. There's a collection of stars, what is available. It's like a map. Hey, we are here on this planet Earth that is belonging to this solar system, to this galaxy. Funny story, we send a message, but in 25,000 years, M13 will move. So even if the message will get there, M13 won't be there anymore. And anyways, if someone is there listening, we have to wait 50,000 here to listen to their reply. And last but not least, the Pinwheel Galaxy in Ursa Major. This is 170,000 light years across, is double the size of the Milky Way, and is located 25 million light years away. Discovered in 1781, not by Messier, although the name is Messier 101, but it was his colleague, Pierre Méchain. Interesting fact, on May 19, 2023, a Japanese astronomer, Koichi Itagaki, discovered a type 2 supernova named SN 2023 IXF inside M101. Funny story, I captured this image of the Pinwheel Galaxy on May 16, 3 days before. So I could have been the discoverer for 3 days. Sorry. And again, T Corona Borealis is still there, is a 10 magnitude star. Every once in a while I take some images to see if something changed. Nothing changed so far. And is a recurring nova. What happened? There is like a binary star. There is a red giant, and there is a dwarf white star. It's a dead star that has a big, big gravity, and is just dropping all the material for the red giant until the amount is enough to make a big bust. And this happened every 80, 86 years. So last time happened at 1946, I believe, and there are signs that there is a accretion rate that is getting higher and higher, but we don't know enough because it was supposed to happen between April and September 2024, and as of today, it didn't happen yet. So keep an eye on this star. How to find out? It's there. So this is, again, Hercules. To the left side of Arcturus, and this is a Corona Borealis, this ring of stars. The yellow circle with the red arrow is where you can find a star. Comets and asteroids. Not much to say for this month. No bright comets visible in June 2025, and also asteroid, there's nothing really happening. Vesta is still bright in the sky, but they reached the opposition last month. International Space Station. There are a few interesting opportunities to see them, and I highlighted in red when the International Space Station reaches its highest magnitude. -3, -2 means that it's very big magnitude, very, very bright, but still happening in the morning, 4 o'clock, 3:44, and so on. There's another passage. And I highlighted the best one that should happen around June 24 at 4:41 a.m. And this map is calculated from my location. Brightness is -3.8. The website where I find is ISS Transit Finder. Sorry, it's events.above.com. And I suggested to look from time to time because, as you know, the International Space Station can be a little bit delayed because there are always stuff happening there. And the thing that are real today, maybe next week will be not real. I mentioned another website, ISS Transit Finder, and this website is telling when the International Space Station can pass in front of the sun, of the moon. And so many times I was sure they was going there. I didn't check like 2 or 3 days before, and it didn't go through. So I was just waiting for the International Space Station to go in front of the moon, but it didn't happen. So always have a look like a few hours before and be sure that your latitude is correct. And with that, I think I'm done. Thank you so much.
Any questions from the audience?
Hi, Claudio. Nice presentation.
Thank you.
The video you showed of Mercury, I think I could see it was like dichotomy. You got it at 50% phase.
Yep.
Did you use any filters to help get that image?
No, it was just a color camera, CMOS camera. I think ACI 224 MC is a color camera on my Celestron 8 as Schmidt-Cassegrain. And the thing that all this color, they're all around because it was very low to the horizon. So it's just a diffraction spiral and just the colors are not real. So Mercury looked like white.
I was wondering if you had like a minus violet filter or something to cut that out.
I don't, probably something I will consider adding to my arsenal very soon.
Thank you.
Any other questions? Oh.
This question is from Shraddha Pai, and I hope I pronounced the name correctly. Can we see noctilucent clouds from Toronto, or do we have to go further north?
That's a good question. Usually, the darker the sky, the better it is because there is a lot of contrast. The problem with the Toronto, the light pollution, you can still probably see and image them, but again, it's like a matter of signal to noise ratio. If you take an image at 30 seconds, for example, the problem is that you're also magnifying the light pollution. You can probably see with the modern DSLR cameras, but I always suggest to go and find a dark spot.
All right, so thank you once again, Claudio. And we will take a short break for fun facts while we switch over to the next presentation. And we're back. So our next speaker is Julian Samuel, who will be talking about using a 60 millimeter solar telescope to make sketches and oil paintings of the sun. Julian.
Thanks. I come to astronomy from an arts background, which is very different from the background that you all probably come from. Most of you come from hard science, science and computer science and engineering. Probably, is that about right? Yeah, I think so. Have you got a good level on the mic? Yes? Closer, okay. So during my high school years, I didn't do well in the sciences, but later on, 5 decades later, in 2019, I returned to adult high school to relearn maths, physics, and chemistry, and these subjects led directly to astronomy. This short talk that I'm going to do is edited with a longer conversation I had with my friend Dave Wilson, who is a journalist who's written some exceptionally good, useful articles connecting science with the public. He writes for Broadview magazine, where he was the editor. So this is an edit of the conversation I did with him on email. His first question is, when did you start doing sun paintings and why? In 2002, I started making sun paintings after I became a member of both the Royal Astronomical Society of Canada, Toronto, and the EC Carr Astronomical Observatory in the Blue Mountains in Ontario, Canada. During a visit to the observatory, the director, Ralph Chu, introduced me to the solar world. He pushed a button and the roof came off, and now I was going to look at the sun through a hydrogen alpha system. The scope produces a burgundy-colored image of the sun called the photosphere. The outer area, the periphery, is called the chromosphere. This wavelength is a lovely 652.28 nanometers in air. It's a very small dimension, but not as small as the Planck length, which some of you know about, and I don't. We are in cycle 25 of the sun, which is a very active period of the sun's life. Ralph set the scope in tracking mode and invited me to look through the eyepiece. Immediately, the sun became alarmingly unfamiliar. The high energy blasts arising from the sun are called prominences. These were causing pareidolia in my mind, which was fabricating similar things: trees as tall as 200,000 kilometers, rows, hedges, bushes on fire, and fish with fins as long as 100,000 kilometers. Stick figures running above and parallel to the sun were crashing on a flaming sea. The stick figures looked like Muybridge's animal locomotion photographs. It was a very dramatic afternoon. I looked through the eyepiece for about 8 minutes continuously, and then slowly a prominence began detaching from the sun. I mean, it looked as though it was detaching. You can't really see motion, but you can see the illusion of motion across 10 minutes, perhaps. I've seen on 2 occasions on the photosphere things that have become ultra bright, then very bright, and then decreasing only slightly. First on 9th of May, 2024, at around 8 in the morning, and then a second time on July the 2nd, 2025, from 7:14 to about 7:16. Both events took about 3 to 5 minutes to fully transpire. Jokingly, my friend Phil Morrow, one of the best solar photographers in Canada, says I ought to change my name to Richard Carrington. Of course, he was joking about the 1st and 2nd September 1859. Detachments are called coronal mass ejections. A particular detachment looked like a conductor throwing up a baton gleefully into the black heavens. Very beautiful things happen when you look at the sun, because it's unpredictable. You don't know if it's going to be the same the next day when you see it. A few days later, these mass ejections become auroras igniting our night skies due to colliding with Earth's magnetoscope sphere. I mean, I'm just learning the basics about all this stuff. I observe our star from a high-rise apartment in Toronto. The sun is changing its intensity continuously. Prominences arise and vanish, sunspots form and dissipate or rotate out of view. Depending on the atmospheric clarity that a particular day contains, I use a Herschel wedge with my 96 millimeter triplet. This special prism enables me to see the sun spots with high contrast. And adding a 7.5 uh, narrowband filter renders the sun a beautiful effulgent green in which the sunspots really pop. I've gotten so used to seeing the sun in green that when I take the filter out and look at it in black and white, somehow it doesn't resemble the ancient jungle that we all grew up in. Um, I sketch at the eyepiece. Question number 2. My sense is that you did nothing but sun paintings for quite a while. What got into you? Yes, nothing but sun paintings. In a bit, I would like to develop your use of the word quite a while. Painting enables me to convert a common object into a visually complex one. As a non-scientist, I attempt to study the basics of the sun. Question number 3. Are the canvases a result of actual observation? The canvases connect my own observations of the eyepiece with current day solar photography by amateur solar photographers and large scale solar telescopes on Earth. So practically all these visual experiences contribute to my actual observation. And I wonder if the view at the eyepiece is influenced by a wide range of solar images that we consult. I'm not sure. I mean, you see it objectively in the eyepiece. It's there. It's got things around it, but somehow I feel that all the images I look at from the National Solar Observatory, the NSO, which operates facilities at several locations throughout the world, Sunspot, New Mexico, Boulder, Colorado, Hawaii, and the images are taken with the Richard B. Dunn Solar Telescope. My friend asks, so if so, is what you see, if so, is what we see what you've seen? I would say no, not at all. And I think this would apply to astrophotographers as well. I don't paint exactly what I see. No painter does. My paintings do not imitate a particular solar photograph, but combine bits from hundreds of solar photographs. I spent hundreds of hours at my 60 millimeter telescope, an LS 60MT, which is a small sized telescope for solar observing. I mean, you can get as high as 100 millimeters safely. Please allow me to link photography with painting. My paintings create apparently realistic views of the sun. The paintings look like the sun, but are they really like the sun as we know it in our day-to-day lives? I think not. The artistic and informative images made by several large, powerful telescopes are created by a human at a computer. This human fabricates images based on an incoming stream of data. I do exactly the same thing, but I use paints and brushes. You mentioned that some of the canvases took months to complete. Why did they take so long? A large part of my life is spent at looking at objects in a range of age from the pyramids of Giza, which are 4,600 years old, to contemporary art, which is 1 or 2 years old. My canvases are a visual log that started collectively a wee while ago. The human tribes started painting celestial objects roughly 40,000 years ago. This is a small span of time compared to the age of our sun, which at midlife is 4.5 billion years old. So now I'm looking at things which are very old. I've never done that before. The moon, another old familiar object, becomes completely unfamiliar when you look at it through a telescope. For example, you've looked at the moon all your life, and then you look at a crater called Fracastorius with the fallen walls, and you'd never think they'd see something with fallen walls on the moon. So the familiar becomes very unfamiliar. Early humans looked up at a black sky that was free of light pollution, free of cave-era billboard advertising, blasting street lights, and retina-smashing white car headlights. These early astro painters hunted and gathered mental images and returned to decorate their cave walls. The caves in France are only one such place where this happened. The act of recording the sky took place everywhere. So in a comical fashion, my paintings have taken not a few months to conclude, but 40,000 years to conclude. How long did it take the human tribe of mathematicians to come up with negative numbers? Ages. When painting, I make error after error until I arrive at the main goal, which is to give the painterly illusion of suspending this one old complex object in a black field. I wonder, why have the caves in France increased in value? It's because of the art in it, not because of the cave, but because of the art. The last question, number 5. Well-known paintings of the sun, Van Gogh, Turner, Monet, etc., lean on yellows, oranges, and typically depict the sun in relation to earthly objects and landscapes. Your paintings lean to reds and show the sun suspended in black with no other points of reference. What's your intention here? I use various reds straight out of the tube. I mix in yellow and orange to imitate what I see. The deep red is the hydrogen alpha telescope, is what the telescope gives me. Thrillingly, our sun is never the same. It's a different red every single time I see it. Also, the high contrast black field is different with every viewing. This variated black field is produced because the scope blocks all the other wavelengths. If the atmospheric conditions are not clear, the red is wonderfully scattered and smeared into the surrounding blackness. Sumato. You mentioned a great painter I feel very close to. Vincent's disciplined palette depicts night scenes such as Starry Night over Rhône, 1888. We know that he painted many of his paintings in a weekend. So compared to me, he painted flawlessly and at the speed of light. He painted in an era which had scientific imagery everywhere, in libraries, in cafes. There's no doubt whatsoever that he knew about the work of Camille Flammarion's popular illustrations, which included drawings of spiral nebula, which we now call galaxies. Please see the stars in the Starry Night, 1889. Vincent used popular scientific imagery, to make these two colossal works. I too am using up-to-date solar photographs and telescopes to paint the universe. So that's it for the little talk, and I just want to quickly take you through the slides that I have. Right arrow. So this is my partner, Julian. We're not in some faraway land like, where I come from, but right here in Orville, which is Blackwater Lake, which is near Orville. Here's looking at the sun with a Herschel wedge. It's an 80 millimeter. And here's the 60 millimeter LS 60 MT. Here are some, all of you did this in high school. I had to do it again in later life to understand how things work. Now, this is where I'd like to harass a scientist in the audience, if there is one. Did many of you do physics? You did, yes. So I have a question for you. Wait for the microphone. Okay. Hey, Frank. So I know this doesn't represent reality, really. It's just a symbol of what possibly is happening. So when the electron falls from level 3 to 2, it gives off that photon, which is 656.28, right? So the question is, what's happening here? I know it's a discrete object. I know that it can either be one thing or another, but what is it here in between the two things? I know this is just some kind of representation of what reality may or may not be, but what's happening here in this stage here? You can ponder that, and I can go through.
Okay, thanks, Tom. So you're trying to say what's happening when the electron is in the intermediate stage, and it's not really, it doesn't really exist in a discrete, indiscrete stage between the two discrete levels. So it wants to be in a level n equals 3 or n equals 2. You
Mm.
don't really see it existing in that metastable state between the two electron levels.
When's that photon released then? When it hits
When it
this
reaches,
ground,
yeah,
when it hits the ground state?
it reaches a stable state, whether it's n equals 2 or n equals 3, and then the electron gives off a certain amount of energy, which it corresponds to that wavelength in the transition from n equals 3 to n equals 2 or n equals 4 to n equals 2 or
Okay.
whatever.
So that's what I spend hours and hours looking
Yeah,
at.
so there's no answer to your question of does the electron exist in that intermediate step?
Okay.
It wants to be in the discrete stages of n equals 3 or n equals 2.
Okay, I'm going to try to understand that. So here are some of the things that I imitate in combination with other things that I see. And here is the Balmer line, which we observe. It's hydrogen alpha going from negative 1.5 electron volts all the way to negative 3.4 electron volts. And that's where the mystery is, which I don't really have the mathematics to grasp, but okay. So here's another image of the sun. Here is this obsessive thing that's been concerning me. Here are some sketches, some basic things that we look at the sun and what they're called. Their plages, their sunspots, their filaments, etc. Pyramids, hedgerows, more of the things that one needs to understand what these patterns repeat themselves in observations in one form or another. I mean, this thing here, which is a broken arc, I see frequently. Claudio, you must see them frequently as well. And this is the bright spot that I saw on 9th of May. It looked like it was happening in real time. It got brighter and brighter and brighter, and then it slowly faded. And Julian Carrington is what I'm going to call myself now. So here are some details. I make a lot of sketches. When I look at the sun with the 7.5 narrowband, on a very clear day, I could see granulation, but it's not often that I can see granulation at all. I can see granulation with the hydrogen alpha, but not with white light. Squeeze through that other filter. It's another sketch. More sketches. You know, a lot of astronomers have a lot of wire jungle around their telescopes. This is what a studio looks like. Pretty junked up, as you can see. There's another painting I did. This is a Messier 11. Doesn't look like a photograph, of course. What's the resolution? These are other paintings I've done. These are attempts at prominences. This is a large one I'm working on. It's 540 centimeters by 92, so about 5 meters big. It's the biggest one I've tried so far, and I should have it done in 40,000 years. Sometimes when I do paintings of the sun, it starts off like the sun ends up resembling Jupiter, and it probably could go back to looking like the sun. Here's the full painting that I'm currently working on. The white is to allow the red to bounce more. Books I've looked at in my voyage in astronomy since I joined. This one was a great book. This one is a fabulous book to read. Requires some knowledge of physics. This is a great general book that I read for astronomy and science. And this is a absolutely clearly written book, which I would recommend to everyone. Mapping the Heavens. It's written in a prose style, which is very clear for non-scientists. And this is, of course, Subrahmanyan Chandrasekhar of the 1.4 solar masses before you get a black hole. It's a great biography of him. And then Who Owns Outer Space? which is great because it deals with the scratching of the night sky with satellites, Birth of Astrophysics. And these two are the great books on the sun. Of course, Pashkov died recently. And I was lucky enough to get an article published in Stephen James O'Mara's column on in astronomy. Here's my own article in Sky and Telescope, published April. And then I wrote a very short novel about amateur astronomy and a romantic comedy. I combined the two genres. And here is basically what's going to happen. At 10 to the 100 years, everything will stop, including our little sun. I got this from Welcome to the Universe book. Who's written it? Do you all know? Welcome to the Universe is written by Tyson. And then this is Isaac's great book, which exists in the Toronto Public in U of T in the Rare Books collection. You can actually go and touch this object if you feel like it. So that's it for my presentation. Any questions?
Yes. Any questions for Julian? Okay.
Okay. Please.
I ran across recently a YouTube video by a doctor, and an interesting point that the doctor made was that in the era of Van Gogh, foxglove was often given as a medicinal.
Sorry?
In the time of Van Gogh, foxglove was often used as a medicine for patients, and Van Gogh was in and out of treatments. So it is believed that he had been given foxglove. Foxglove is a poison, but in small amounts currently it is used for I believe a heart medication. But the one aspect of the foxglove, if you eat some foxglove, is that it makes you see halos. So that might be the reason why he drew halos or painted halos around stars. That might have been what he saw because of the foxglove.
I'm not competent enough to answer the question. The evidence that we have is the conventional one that I mentioned, which is that he was aware of Flammarion's work, and his pictures were all over the place. So it could have been a composition. It could have been a combination of the drug that he was being administered and what he saw in the science books. Maybe it's a very rough guess, but I'm not an art historian. I couldn't comment more than that on that point.
All right, then I'd like to also make one comment.
Please.
So, Julian, one thing we try to do as amateur astronomers is keep the math to a minimum. Math and the physics to a minimum. I'd like to say that you, contrary to what you may be feeling at the moment, you may actually be ahead of several of the people in the audience when it comes to understanding some of the physics that are here, that are involved. Because, like I said, a lot of us are here to look through a telescope and are not super concerned with the actual physics of the universe. For that, I salute you, sir.
Yeah, but it's a terrific fun to understand things visually. I mean, when you look at the sun, you're thinking, well, what is this thing? There must be a way to understand it with numbers as well. Astrophotographers get closer to it because they're dealing with filters, they're dealing with time, they're dealing with sidereal time, they're dealing with a lot of things. But this whole voyage into astronomy has been really a wonderful acid trip. You know, you learn things every time. Every time I go to the CAO, something new pops up. right? Something, you meet someone who is from a hard science background, and will say, well, I can explain that according to exactly what you said. You can't really tell me exactly what's happened between the two states, but you know that something happened. So these things are a preoccupation, and it's tons of fun being especially going to the CAO. Thanks a lot.
All right, ladies and gentlemen, and we'll head to fun facts while we get set up for our last presentation of the evening. And time for our final presentation of the evening. Frank Dempsey, some updates on the telescope loan program from the Toronto Centre. Frank?
Okay, thanks, Tom. So we're all set. Okay, so I will, as the title says, just have a few updates on the telescope loan program, which some members are aware of. That there is a telescope loan program where members can go online to the webpage of the Toronto Centre RASC, find the telescope loan program website, and reserve a telescope to borrow for 2 weeks, in case you weren't aware of that. But my point here is to provide an update. So the few updates I want to present are some telescopes that are now available, some training on basic telescope use, and some resources for beginning observers. Reason this is an update is because last autumn, maybe September, October, I stood here with some updates as well, and I requested any members that had parts, old telescopes lying around in drawers, eyepieces, diagonals, finders, small telescopes, refractors they weren't using. I pointed out I could put them to use for the telescope loan program, and I also requested any beginner sort of books that people had they weren't really using. They wanted to donate them so I could loan them out to telescope loaners as well. That was the point of the resources. So this is an update. Oh, you see a pretty picture there. So what's that about? I don't like putting up a slide of text and boring text, so I thought maybe I can find a pretty picture somewhere to throw in. So that's about. Okay. In motivation for the telescope editions, I'll say that I've been one of the volunteers for the telescope loan program for maybe 5 years. That includes COVID years, which you don't want to talk about too much. So let's say maybe a few years I've been loaning out telescopes to people who want to borrow one. And so the beginning telescopes have been a couple of 8-inch or 200 millimeter Schmidt Cassegrains. There's also a 8-inch Dobsonian, which another volunteer administers. So that's one of the options. And so, but the ones that I administer and questions I often get referred to for somebody asking, want to borrow these telescopes or whatever's available available for a telescope to borrow. And typically it ends up being the 200 millimeter 8-inch Schmidt Cassegrains, which I administer. I have at home when I meet somebody who wants to borrow it, and we loan it out for 2 weeks. However, what really bothers me is that it's not appropriate for everybody. So I've had enough small ladies come with small 10-year-old children. They're really enthusiastic to use a telescope, and they get this 8-inch Schmidt Cassegrain. And for some people in the room, it's no problem to handle it. For a lot of other people, should say it takes some shoulder and back muscles to handle an 8-inch McCassie grain and load it onto the tripod. It takes some effort. It takes some know-how. There's a lot of little parts involved, and so it really bothers me that we haven't had anything simpler that real beginners could actually borrow. And so that's what I've tried to access here. And so I'll point out a few examples. Here, the one on the upper right picture you see is a plastic telescope, which one borrower, one person came to me and asked if I had something better than this. And I have to say that she paid good money for the kid, even bought a warranty on it from looks like or some Toys R Us store. But it's a plastic tripod and a plastic tube with a plastic lens in the refractor. So I'd have to say the only two good things about this are that the duffel bag is pretty good and it's pretty lightweight. Otherwise, the telescope was really, really suboptimum, to put it mildly, to be polite about it. So the one on the bottom, you may see ads like this from time to time. 60 millimeter refractor and advertised with 675 power magnification. See, there's something wrong here. So yeah, we shouldn't see too many ads like this, but we do. So there are some misleading ads that may appeal to people wanting to get a telescope for the first time. A couple of other examples. Here's an ad that I found online. So telescope for sale. Don't know what size it is, but it's a telescope for sale. If you, is there anything wrong with this picture? You might say the finder is pointed the wrong direction. And so does the seller know that? Doesn't seem to care. And so the point would be, if somebody goes to buy a telescope for this guy that's selling it, would you trust that person to demonstrate how to use it properly? Probably not. So one other example I have here is when somebody comes with a telescope and it's a box of parts, box of metal parts. It's not plastic. It's not a plastic tripod. It's good quality machine metal parts. However, it's going to be a mess. Such a mess to set up in the dark with cold hands. It just won't get done. I assure you of that. Especially when you see something like Allen keys, an Allen key in a Ziploc plastic bag, and a whole bunch of parts that have to be assembled carefully. So a bunch of no-nos that really are in the face of first-time telescope users having fun, enjoying the hobby. So I wanted to try to do something about that. So there's a few things I wanted to point out here that I've added since last September or October. And one of the things I pointed out was anybody has a small telescope wanted to donate or a manual equatorial mount, I'd be glad to put it to use. And I got some. And so an EQ3 equatorial mount, 90 millimeter refractor, and a Meade 114 millimeter Newtonian reflector. Those are the things I have. Late breaking news, I just found out tonight at this meeting, also being offered an 8-inch Smith Cassegrain telescope for further use as well. So we'll see how that one works out. Another pretty picture because it's a face full of boring text. So let's get on to some pictures. So the EQ3 equatorial mount, currently, as you see in the upper left, tripod and a box. And you open the box and there's the mount and the counterweight. And lift it out with one hand. Most people, one hand will do it, and some people are smaller, of course, and might take two hands. That's fine. For me, the point is that my hand gives a sense of scale, what size it is. So you may be familiar with EQ3 mount, and I have to say it's identical to another mount which I use quite a lot called a Celestron CG4. It's a long story why I have 3 of them, but I use them quite a lot for a lot of my telescopes. So it's as simple as pulling this mount out of the box, put the counterweight onto the counterweight shaft, put the tube, take a tube, telescope tube, put it onto the mount and tighten it up. And really, if you're not familiar with dovetail mounts, you have a dovetail base on the mount and a dovetail bar on the telescope, and it slides in into the dovetail, and you tighten up the knob, and it's that's simple. That's all there is to mounting the telescope. Okay, and that's what you see in the lower right-hand picture, I guess. So that's all there is to say about the mount. It's pretty darn handy, and it works pretty well. And it's manual controlled. So if you don't see it here, there are 2 slow-motion manual control knobs on it, which I think is a very good way to learn to use a telescope. Just my opinion, because that's what I do. For comparison, you see a picture of my one of my CG4 mounts. It's identical, except that Celestron paints it a different color. Puts a different nameplate on it. Otherwise, I have several of these. I have 3 of them actually, and you see again, lift it out with one hand, put the counterweight on, and that's all there is to it, setting it up. So the picture on the right, so if you remember that box of parts I showed you on the ground didn't have the telescope tube in it. The telescope tube is that one you see on the right-hand side with that little Newtonian reflector. It just simply mounts into the mount with dovetail I showed you, and it's really that simple. It doesn't require that whole box of parts to be assembled. All it requires is to take this mount out of the box, put it to the tripod with one little hand bolt at the top of the tripod, put the counterweight on, and put the telescope in, and it's ready to go. First, just to let you know, reason I set it up this way is because I've been doing this for years for dark sky observing trips. So I have a few other mounts. One in the lower left is my Celestron AVX equatorial mount, which you may be or may not be familiar with. Fairly common mount, I think. It's a good mid-size telescope mount. I actually got it originally for use with my 6-inch Newtonian reflector that I made about half a century ago. It's still my favorite telescope, but it's a good mount for that. And so the one on the lower right is a heavier duty, bigger Lost Mandy mount, which is, I definitely don't lift it out with one hand, I assure you of that. But the point is that it's really easy to transport it in a box, throw it into a vehicle, pile stuff around it. It's protected, and it's easy to lift out of the box, put onto the tripod, and put the counterweights on, and it's ready to go. And so that's why I've set up the EQ3 mount in that way. So the 90 millimeter refractor is a Celestron refractor. You see in the left, it's in its box, which I made for it. You simply lift it out of the box. You put it on, there's a dovetail and fits into the dovetail base on the tripod again. Insert a finder and insert the eyepiece. And so I'd have to say that you don't need to do any quantum chemistry or physics calculations to figure out where to put it. You don't need to have a physics degree. You don't need to worry about the Balmer transition series of hydrogen or any other atoms to calculate what to put where. You put the eyepiece in, you rack out the focuser maybe that far, and it's ready to go. It does a good job. It's fine. It's that easy to set up. No calculations required. That's that refractor, and so I put the picture on the left. It shows that you don't even need the finder because it's really easy to sight along the tube. This was a few nights ago when the moon was actually visible in the sky before it got smoked out. So the moon is actually in that picture, but it's not exposed properly, of course. But the point was that of that picture on the left, that it's really easy to sight along the tube with that refractor, and get it into a low power eyepiece field of view. The picture on the top right, I was using that telescope to observe the planet Venus one morning. So I thought for comparison, just for fun, I'd pull out my approximately 5-inch Celestron refractor, which I think is a really, really nice telescope. For comparison, compare the two. A 5-inch, I don't know, it might be 120 millimeter, might be 127 millimeter, take your pick, or you might be familiar with it. I don't worry about the details too much. It was just fun to compare them side by side. Then I pulled out my 4-inch, or actually Celestron 102 refractor. That's the one in the lower left. You see it's in the middle with the this 90 millimeter refractor on the right and my 5-inch Celestron refractor on the left. So I compared the three side by side. I just find small refractors fun to use and really easy to use, and it's really a fun little telescope to use. I made a little sketch of the moon, one of the moon craters, a few nights ago with that telescope. And again, you don't need to worry about Balmer transition series calculations for hydrogen atoms or anything. If you want, you can picture the temperature differences as the sun rises, cast shadows of the craters on the mountains as the sun rises. But it's just one example of what you can see with this telescope. That's one. The Meade-Newtonian reflector. Again, I lifted it out of the box, placed it onto the mount, as you see in the upper left, and it's ready to go, and pictured on the upper right. And again, another crater I sketched with it, using that just to show that it works. So I think it's a nice size of a telescope. Now this is an interesting telescope. The way this came to the telescope loan program, I should point out, it got rescued from the garbage. And so, so about a year or so ago, somebody posted on the forum that they saw this telescope in the garbage waiting to be picked up. And does anybody want it? Anybody have any use for it? So I replied, yes, I'd be glad to come and rescue it, come and grab it, fix it up, get it ready for it could really be useful for the telescope loan program, this sort of a small telescope. So I drove to Toronto, picked it up at the guy's place, and it was really literally minutes from getting picked up by the curbside garbage pickup at somebody's house, at this guy's neighbor's house. A little bit messed up. Focuser was damaged beyond repair, so You can't tell from that picture in the upper left. That's the original focuser. I found another focuser for it. So it's on there now. And 2 rings in the middle. Mount them onto a dovetail plate, Vixen dovetail plate, and it works pretty well that way. And then clean up the optics a little bit. So some work on it. It's ready to go. So it's a really good little telescope, in my opinion. It's a good portable telescope, and anybody that wants to borrow it as a first time telescope using a small telescope would find it quite fun. And as I mentioned, it's easy to do sketches of the craters and other details. If Jupiter were visible, I could have made a nice little sketch of Jupiter, and so it's a pretty handy telescope in my opinion. Let's see, is there anything else? Oh yes, I should mention also one donation I got last year was a Celestron 10 by 50 millimeter binoculars. They're pretty darn good. They're really good astro binoculars. So I thought not much to say about it, so I thought I'd throw that in. Second part of the updates I wanted to mention was training. So I decided to start a training program. So I will offer custom training sessions to anybody, for any member for any reason. So the reason I decided this was because a number of the people coming to borrow the 8-inch or 200 millimeter Schmidt Cassegrains for the first time find it really darn awkward to use, especially if they're using a telescope for the first time and not familiar with the sky. And I'd have to say that Schmidt Cassegrain telescopes are not optimal first telescopes for seeing the movement of stars across the sky or the movements in the sky. So I decided that a manual equatorial mount is a really ideal way to illustrate it. Ideally, we'd meet for somebody who wants training in a daylight for an hour or so or less, and just show how it works and snap the telescope together onto the mount and show how stars move across the sky and the slow motion controls and how you put the eyepiece in. So for anybody that wants that training, I decided to start this, and at least one other member has come forward offering the training as well. His idea was offer anybody with any telescope problem at all could come and ask for help, and we'd find somebody that would be able to help. So that'll get interesting when somebody starts asking questions like, how do you set some software settings on some complicated mount? Like, you might see questions on Cloudy Nights forums and so on. They're pretty complicated questions about pretty complicated mounts. So that could get interesting. But I thought for basic elementary training for understanding how the sky works and how the telescope moves, that was the idea of offering this training. So anybody can email me. My email's at the end on the summary slide, and I think I had a note on the forum, Toronto Center forum about a month ago, and it could reply to that too if you want to. I mentioned resources. So there are some really good resources that are available in terms of some books that are available. And some of you may have these and may say one or the other is really darn good and an excellent book. And you may find these, they may be sitting on a shelf at the Toronto Center Spaces at the CAO or the DDO, or may even be in a public library. I know Night Watch is in quite a lot of libraries. So there's some pretty good books, but I thought originally when I asked for any resources anybody wanted to donate last autumn, somebody might come forward with books. However, I found a better resource actually. So I could mention here that I set up my own little setup guide for those Schmidt Cassegrain telescopes and include the manual. Includes it all. I include a lot of stuff in a binder. So just a little 3-ring binder to hand out with somebody if they want it, if they want to borrow it. Has a telescope manual and a whole pile of other resources in there. I'll show you a few of the resources. So I decided give them a basic sky map. So you go to skymaps.com. You print out a star chart for each month, and quite a lot of good resources on here for what to see with unaided eye or binoculars or small telescopes. So it's a really good resource, I think, to get somebody started. And make sure they have moon maps and a little planisphere, which are also in this little binder. I offer them. I decided this very old book, which I've had for probably half a century, is an excellent resource. And so once I found out that its copyright had expired, and it's actually online, and it's probably legal to photocopy it and hand out photocopies, I decided to do that. So some of the pages I've pulled out, maybe roughly 15 to 20 pages, and put into this little binder, include charts, very good diagrams about how to use a telescope, how to get started with finding sky objects. And these are, and you see it's a little subset of the book actually. And so those are the resources I decided to set up that would be pretty helpful to beginning observers, in my opinion. So in summary, I've tried to point out that I recognize there's a need for some beginner-friendly telescopes, and they're now available. They will be posted at the Telescope Loan Program website. They're not there right now. There's some administration to go through and need to be barcoded as Toronto Center assets and some other little details. And I mentioned that training is available and resources to help beginners are already available in this little book, this little 3-ring binder, which I will hand out to anybody who wants it when they borrow a telescope. So you have my email address. And so I think I'll stop there and we're finished. So thank you very much for your time.
Thank you very much, Frank. Any questions from the audience?
Frank, thanks. An unrelated question about observing it during the summer. If you have an electrical outlet nearby, would you use a fan to push away the mosquitoes? Would it work?
Yes, a really powerful fan will push them away. If it's greater than their speed is greater than their flying speed, yes, we'll keep them away.
Any questions online, Betty?
Question, but a comment, but maybe it could be turned into a question. Swanita13 said, wish I currently lived closer to borrow a telescope. So that's a question.
So no, it's a very interesting comment because the biggest hassle for Telescope Loan Program borrowers is getting to me. So if they contact me, if they contact the other 2 volunteers, one guy maintains stuff, solar observing and imaging equipment. He lives in Toronto. Kamesh, I think, lives in Western Toronto somewhere. Same problem. He complained to me about having to drive all the way to meet me in Pickering to borrow the 8-inch Dob when I had it. And I told him that, fine, had more volunteers to do this, to offer the telescopes, maintain telescopes for other members. They live in Toronto. That would help out quite a lot of people. And the benefit is he could use the telescope when it's not being loaned out. So he thought, yeah, that makes sense. So that's why he maintained the telescope now, the 8-inch Dobsonian in the Telescope Loan Program. So yes, it's a strong comment that anybody who wants to borrow the telescopes, which I'm maintaining, has to come to Pickering to meet me because that's where I live. So I generally try to meet them near Highway 401 or 407. And I know it's not easy driving across Toronto. That's the biggest part of the job. Otherwise, they take away a $1,000 telescope for 2 weeks, and I hope that they'll bring it back. But the biggest effort is arranging an appointment with me. We have to juggle and arrange some time to meet, and they have to come to Pickering to pick it up. So yes, it's a bit of hassle.
Oh, thank you.
Okay, is that a question? Nope. Okay.
Microphone. I can, but microphone is for the benefit of people online.
Do you think, okay, for going to, I think you have 3 observing places. One is the Bayview Park, right? The other is the Dunlap, and the other is the Dunlap Observatory, and the other is in Pickering. Was it a Millennium Square? Okay. Is there like public transportation to those areas, or do people need cars and stuff?
I would say, having been to the Bayview Village, anybody else wants to comment? But yes, it's easily accessible by public transportation. I'm guessing because it's Bayview Village.
Yeah, Bayview Village would be it.
Yep. DDO, not really. It's a long walk. Millennium Square, not really. It's a long walk too.
Oh, okay.
It's about a good probably 2 kilometers south of the Pickering GO station. And yes, there's bus service, but practically speaking, no. But now that you mentioned those 3 resources, I should also mention that in addition to the training for telescope, which I'm offering to meet somebody to do that, people can gain good telescope training by showing up to one of those events, Bayview Village or Millennium Square or CAO or the other events from time to time, and meet people that know what they're doing and will offer help. So I'm glad you mentioned that. So, okay. But in terms of walking to those events, I think Bayview Village is the main one that would be accessible by public transit.
Okay.
Question at the back?
Thank you. Hello, good night. I just have a question in terms of the telescope. So, do you have a general advice in terms of the maintenance of these small telescopes?
Maintenance of telescopes? Yes.
Because I know that perhaps it is a clear sky, but the wind could be pretty heavy for it. So,
The
do
what
you
could
have
be
a-
heavy?
Yeah,
What could be heavy?
wind. The
Wind.
wind.
Yes. Yes, that's a very good point. Because let me mention my point is that a long telescope will be more prone to wind vibration, and so the 5-inch or 114 millimeter, which is about 4.5 inches in ancient old-fashioned units, 114 millimeter Newtonian is not a really long telescope, not really strongly wind prone. That's my opinion. I have probably 4 or 5-inch telescopes, and so they're. I think it's quite useful, even in reasonable winds. Refractor will be a bit more vibration prone. The Schmidt-Cassegrains are easy to use in strong winds because they have a very small wind profile, so they're easy to use. That's for use in winds. You mentioned maintenance, so I should mention a great benefit of the telescopes I mentioned for maintenance. Had enough people borrow a telescope and come to me and say, "Oh, I looked up on YouTube and first thing I do is collimate the telescope and polar align it and so on." And so I try to tell them with these small telescopes, no, these are plain easy to use because no collimation is required. I confirm the telescope is in good condition before I loan it out, and they're pretty robust against transport in a box and being shaken around and not really losing collimation. So those telescopes are ideal for that. The other point is that polar alignment is also a non-issue because with a manual equatorial mount, I tell people, especially with the Schmidt-Cassegrains, where it's confusing if they're not familiar with North Celestial Pole and rotation of the celestial sphere around the pole and not familiar with those basic concepts. They look up on some YouTube thing that they have to do an accurate polar alignment, and I tell them, no, you don't have to. You can even point it west or point it south or east, and telescope will still work. It won't have good star tracking or any star tracking, but you can still use the telescope. So in terms of maintenance, setup and use, these small telescopes are plain easy to use, and the issues of maintenance like collimation or setting up are basically non-existent or trivial. So that's one reason why these are really easy, fun telescopes to use for beginners. So I'm glad you asked that.
Thanks so much.
Thanks.
All right. Anybody else? No? Okay. Then we'll quickly go over to fun facts one more time while we set up for the announcements. Thank you again, Frank. So, as I said earlier, Scott is unavailable, so I'm taking care of the announcements this evening, and I'll be doing so for the next couple of meetings as well. So, let's get into it. So, I'd just like to say hello and welcome to everyone joining us online and everyone who's here in person. This is one of two types of meetings that we have with the Toronto Centre. You've just had one of our recreational astronomy night meetings, which are both in person here at York University and online, live on YouTube. And we also have speakers nights, which are right now are off for the summer break, and those will be restarting in September. For those of you joining us live, please use the YouTube chat, ask some questions for the presenters, as others have done already. And if you are a new member, introduce yourself and tell us where you're coming from. So our next recreational astronomy night is Wednesday, July 7th, right here at York University, 7:30 p.m. to 9:30 p.m., both in person and online. So we're still looking for someone to do the sky this month. And Shraddha Pai will be talking about moonbows and Milky Ways, my stargazing adventure in the rainforests of Kauai. It's one of the islands in Hawaii. I can't pronounce it. And then we also have one additional empty spot. I just want to remind folks, we really need someone to do the sky this month. I can't do it because if you recall, the last time that I hosted, made a presentation, and did the announcements all in one show, the Science Center was shut down. So we're not tempting fate again. Anyway. Now, during the summer months, the Carswell Observatory offers tours on Wednesday evenings. The telescopes are going to be open after the RAN, and it's just down the hall, a few doors down. And during the warmer months, we also are setting up some telescopes on the Arboretum parking lot. That's the large parking structure immediately to the south of the Petrie Science Building. Obviously not tonight because it's raining, and even if there wasn't any rain, the smoke from the fires in northern Canada makes the sky look a little like something out of Blade Runner. So for future reference, though. Coming up at the DDO in the next little while, on Saturday, June the 7th, is Seeing Double Stars with the Rask's Benjamin Law. Details are on our website as well as registration links. Then on Saturday, June 14th, is DDO Astronomy Night. Again, registration links are on our website, raskto.ca. And then on Sunday, June 29th, is DDO Sunday Sun Gazing, 12:30 to 1:30 p.m. And again, registration links can be found on our website. Now, special event. On the first clear night between June 23rd and July 4th is the Open Air Astro Fair from 5 to 11 p.m. This is an in-person event right here, York University, on the roof of the Arboretum parking garage, as I stated earlier. So event partners, including Space Place Canada, the Dunlap Institute from U of T, Telescopes Canada, and Rask Toronto Centre will have tables at this fair. And we're going to be offering folks views through the telescope at both the sun and after dark. So because this is an event that is very weather dependent, the final no-go for this event will be sent out at 9 a.m. the day that it's confirmed. Please, if you're volunteering, if you'd like to help out, please indicate if you're interested and if you're free on what dates. We do not expect everyone to be able to sign up for every single day. That's just, yeah. We'll add you to the email list. So please let us know if you'd like to volunteer. Then coming up at Millennium Square is a free public star party on July 4th or 5th, weather depending, 7 p.m. to midnight. Join us for an evening of free public stargazing along the north shore of Lake Ontario at Millennium Square. You can see the sun, sunspots, and prominences, and then as things get darker, observe the moon, stars through our telescopes. We'll have some astronomy literature set up at the info booth. Ask us some questions about the stars and the planets, and you can bring along your own telescope, and we'll help you set it up and aim it at the moon. Just a reminder, things are usually cooler down by the lake, and please check out our website for a go, no-go decision based on the weather. Our next Bayview Village Park City Star Party is the last week of July. So it's the first clear night, Monday, Tuesday, or Thursday of that week. First clear night. Please check our website for a go, no-go decision based on the weather. And also, another reminder to save the date, the 2025 Open House and Awards Picnic will be happening at the Carr Astronomical Observatory near Collingwood on Saturday, July 26th. We'll have awards presentations, tours of the observatory. We'll be firing some rockets off, and maybe they'll even come back down. We'll have a barbecue potluck dinner and more. The event is rain or shine and is open to members and their families. CAO access is CAO is open for your enjoyment. Masking is optional, and you can see on the see the online booking page for all details. This is where I get to plug the joys of RASC membership. We are a volunteer organization. We'd love to have you join us. You can renew or sign up online at secure.rasc.ca. Gift memberships are available at National Office via mempub at rasc.ca. We run on clean, renewable volunteer energy. If you like what you see and you'd like to help out, if you'd like to help Frank with the telescope loan program, and you're a Toronto Center member, please drop us a note at volunteer@rascto.ca. Perhaps the most important part of the RAN meeting is the meeting after the meeting. We adjourn to the VMV's Bar and Grill, which is southeast of York University campus. If you're parked here on campus, when you exit the parking lots, turn left onto the Pond Road, take it all the way around campus, and then when it reaches Keel Street, just go across through the lights and you enter the parking lot from the south. And with that, I'd like to wish you all a very pleasant evening. Thank you very much for joining us. Please follow us on all the forms of social media we've got listed here. Be safe and keep looking up. Good night, everybody.